Yeah. Put it, keep it on your tummy. No, seriously.
I can't see you, but no, I can't hear you, but I can see you.
Hello?
You get the air
Clear?
No, your hand.
No. Bring it further down a bit. Your mic further down a bit.
Alright.
Janganlah. No. Okay.
Yeah, hello?
Yeah,
okay.
that's right.
Actually, I didn't want to wear the jacket today, but the new t-shirt showing my nipples off.
Your nipples off.
It's showing my nipples off, so I need to wear the jacket. But luckily no ladies here. Yeah.
It's a ladies' costume.
You want us to rewind some?
Guys,
another one also, I have to apologize because I don't know what happened. I think since the great party last night, I thought it was box grinder in the morning, and after lunch was over. So this slide actually is not being fully ready yet. But the box grinder one is already ready, but I cannot change the slot. Okay, so hopefully you can bear with me, but we make it a very, oops. People also here. No, now I'm really nervous. People also here. Okay, so we make it a very interactive session, right? So if you want to know more information, because I have a slide for oVirt, but I thought it was very technical. So if you want to be very technical, I can show you some of the slides. But I think a better way to approach this is just for mere understanding what is this, what is oVirt, what's going on, what does it solve, and everything, right? Okay, so before I start, just want to know, everyone familiar with virtualization here? Yes. Everyone okay? You are doing it for life, man. Anyone else? Who doesn't know anything about virtualization in this room? Definitely. You're kidding me, man. Okay, so I assume everyone knows about virtualization, right? So that's the start. That's my name. That's my FAS, but I already forgot the password. I don't know what's the password anymore. I need to do a reset now. So it's me on Twitter and on Fedora, right? So this is virtualization, right? So what happened is, before this we have one hardware, one application, one operating system, one hardware, one application, one operating system. So now we are going into this model where we have one hardware, multiple OS, multiple application on a single hardware, right? So what happens when we do that is the amount of server that we need before, for example, we need 3 servers to solve one application or one problem. Now we only have 1 server, we can run multiple applications, and now the server in the data center can be from maybe 3, now you only need 1 to cater for the same task, right? So we have less hardware. Okay, so virtualization, some vocabularies that you need to understand. So VM is virtual machine. Virtual machine is the machine that you are virtualizing, as you can see here. So this is a VM. So this is a virtual machine, right? Each and every one of virtualization running inside the hardware is a virtual machine. So you have the term hypervisor, and VMM is actually virtual machine monitor. So it's used interchangeably. So either use hypervisor or use virtual machine monitor. More or less, it means the same thing. It's the technology that powering virtualization, right? So you have guest OS. It's the same meaning with VM. Host OS is the hardware itself. For example here, so so this is the host, and this is the guest, right? So host is the one running on physical, guest is the one running on virtual, right? So we have a para-virtualized guest, the guest that is modified to have a knowledge of VMM, mostly Zen, so we ignore Zen today. So another one is full virtualization, the guest OS is run on unmodified. So what happens is, if you do virtualization using Zen, your kernel between your host and the guest actually knows each other. Right, you have to modify. But what if the OS like Windows, you can't modify the kernel? So you use full virtualization, which means there's no modification on the guest OS. It runs just like it runs on the physical machine. So that is full virtualization. So What is KVM virtualization? So before we go to oVirt, we need to have a understanding of KVM, right? KVM is already in Fedora. It's been a long time in Fedora. So it's a kernel-based virtual machine where it turns Linux into a hypervisor. It's already integrated since 2007 and it needs support from the hardware, right? If you buy a notebook today, more or less it is supported, more or less. But you buy a server since 2007-2008 period, it's already there, the support. But the new ones have better features, better support, and better performance, right? So the benefit is we leverage, meaning we don't need to reinvent the entire hypervisor experience because we already have Linux for the drivers, for the performance, to manage your memory, to manage your CPU, and ease of management, meaning you are using the same tool to manage physical and virtual hypervisor. So this is the slide yesterday. If you can see, this is what Linux already have, right? We already have a very good memory management, we have very good power management, we can support very good CPU scheduling, fiber channel, we have clustering technology, we have a good file system, whereas KVM adds the 0.5%, literally. Drivers for Intel VT and AMD. So you are using the entire Linux kernel to manage your file, to do your CPU scheduling, to manage your memory, everything. But you use KVM and it's a module, means you can turn it on or turn it off when you want to run it. So it only manages the CPU part, right? So that's KVM. Whereas if you can see other virtualization vendors, they need to rebuild all this. I mean, you talk about something like VMware, they need to rebuild the entire thing, memory management, power management. It's like building a new OS. So hypervisor literally can be understood as operating system to manage another virtual operating system, something like that. It means you need the hypervisor in order to manage your virtual machine. So hypervisor is the OS for the virtual OS running on your physical hardware, right? So everyone still here? Still okay?
Yep.
Okay, yeah? Right.
Try this Windows.
So this is where KVM sits. So this is your Linux kernel. This is KVM as a module, and this is your virtual machine, your Windows XP or your Linux running on top of KVM. But because it's still Linux, you can still run your normal application on Linux, your web server, your Firefox, and this is your hardware layer, right? This is your RAM, your CPU, your hard disk. So this is where KVM sits. It's a module, part of Linux kernel. The moment you need virtualization, you can power it up and it will manage your virtual machines. Okay, still clear? Right. So, then you understand the KVM. So what the hell is oVirt, right? What's oVirt? So oVirt is a large-scale centralized management for server and desktop virtualization. So what happens is, when you do virtualization, if it's only a single server, as you can see from this slide here, so if it's only a single server, from 3 to 1 server, it's still able to manage. From 6 server to 2 server, you still manage 2 server. What happens if you have maybe 10 of this or 6 of this, and each machine has 10 virtual machines inside? How do you want to manage a very big environment? So virtualization by itself, we have KVM, good performance and everything. But how you want to manage it in a very big environment? Okay, you have, for example, you have 10 hardware. Each hardware has 10 virtual machines. So you have already 1,000 virtual machines running in your environment. So how do you want to manage that, right? Imagine. So that is actually what oVirt is. oVirt is the management tools for KVM. So it's a large-scale centralized management server based on KVM, provide open source alternative to vCenter vSphere. This is actually especially VMware. So focus on KVM for best integration performance and focus on ease of use and deployment. So for example, you have multiple server. You have two, for example, here. You're running your hypervisor, and you have a storage. You have your network. So all this environment is managed from behind here, from a single web interface. So that is actually what oVirt is. It's the management tools, right? And the hypervisor. It's a collection, it's a full-fledged enterprise virtualization technology, right? So how does it look like? Something like this, right? As you can see here, this is your oVirt manager. So from here you can see all the virtual machine. It's Kaka there. Remember already lost. Chelsea is the one, the European champion. Yeah. So, so if you can see here, this is where you see all your systems. So you have iSCSI storage technology. Then you have your storage, you have your cluster, and from this cluster you have all this virtual machine. The green one is actually running. Right? I will show you a demo later. But the green one is running, and this is all your information that you can get from a single interface. So that is oVirt. Alright, the management tool. So if you are into enterprise, if you are doing virtualization for living or something, there's another product that Red Hat sells with subscription and support. It calls Red Hat Enterprise Virtualization, but this is the open source project. It's like the Fedora of Ref, something like that. So this is fully open source. You can download, you can manage your entire environment using this, and it's based on Fedora, right? So what is the goals of oVirt? To build a community around all levels of virtualization stack. So now we have Fedora, and Fedora is for operating system. We also have JBoss. JBoss is application server, Java and stuff like that. But we need an umbrella community for virtualization open source. So that's where oVirt comes in. It's like it's to build a community around all levels of virtualization, from the hypervisor, from the manager, from the GUI, from the API, and stuff like that. And also to deliver cohesive, complete stack, basically reusable component for open virtualization, provide a release of project, and focus on management of KVM. So the focus is KVM. So they still will enhance whatever KVM does today and provide a better management out of it, and provide a value for user and developer communication and coordination, right? So this is like the Fedora for virtualization. So what do we have today? So this is what we have today. We have high availability. You can restart gas VM from failed host. We have live migration, system scheduler, power saver, maintenance manager, image management, monitoring, reporting. We see some of them. Okay. First thing, high availability. So what happens is, if you have 3 hypervisor here, right? You have 3 physical server. Each physical server running virtual machine here. So this is all the virtual machine, and this is storage. So for example, if your host here is down, your physical hardware down, going down for whatever reason, network or power supply, or suddenly it burns or something, alright? So all the virtual machines that is still running in here will be automatically restarted on another host, automatically, just by policy. So you just say, okay, this hardware, this VM is highly available, all the 3 of them, is very critical. So the moment this hardware is going down, the hypervisor, the oVirt will move the virtual machine to another host automatically. You don't have to do anything. So for example, if you are doing IT, so suddenly the system down for maybe for a while, and the your user is calling you, hey, where's your machine down, everything? Yeah, please check back again. So it's already out because it's automatically being managed, right? So it's a very cool feature. Another one, we have live migration. So if the virtual machine here is running, so you can move it to another physical hardware. So this is, say for example, this is the physical hardware it runs before. You can move it without downtime to another host. Alright, you just move your VM just like that. Okay, from host A, move to host B. Nothing, it's not down. The system is still running. The services is still running. Right? It's live. You can also do scheduling. So, for example, this guy over here has 3 VM. This guy has 1 VM. So the load here is 90%. Here is 30%. So 90% is already critical. So what happens is, if you schedule it, you use system scheduler, it will automatically balance the workload. So each host has 2 virtual machines running. So you can balance your workload. So not one server is being really working hard, and then the server go relax, vacation Hawaii or something. So everyone is working on the same workload. So power saver, you can even use, for example, during the day. So the workloads, the server are running really, they're doing a lot of work, right? Because users log in, everyone is working and everything. But during the night, the server utilization is very low because everybody's gone home. Nobody in the office doing work. So what happens is oVirt can shut down some of the server and move the workloads to the other server upon hitting certain threshold. For example, okay, if the server is 20% utilization, okay, move the virtual machine to another host and shut down that machine. So in the morning, when the user is coming back, so it detects utilization is now 60%. So all the server will be started back, and the virtual machine will be moved to the original host. So you can even do that policy. Okay, some of the management feature. This is some of it. There are lots more, but this is some of the highlight of it. So some of the management that we have. Availability, all this, I think it's the same slide. Okay, I think it's the same slide. This is to manage all of those. So for virtual desktop infrastructure, VDI. So not only we can do server virtualization, which is we can manage your server in virtual environment, we can even manage your desktop. Right? There's a protocol that Red Hat open source. It's called SPICE. Right? SPICE is open source. It's in Fedora since Fedora 14, if I remember correctly. So it's a centralized management, security, enforcement, and it's virtual desktop user experience on physical PC. So the desktop is from your oVirt environment. It's on your data center, but you can push the desktop to your user. You can get all these features, right? So for example, you log in. What happens is in the morning, maybe you have a thin client, or you need some special application that is only in the data center. So you log into your web browser. You see whatever desktop that you have, and from there you click. The desktop is being transferred from the data center to you, right? And you can use multiple monitor, HD quality video, bidirectional audio, everything works just like a normal desktop. But the desktop is actually in your data center. It's not in your computer, but it's being pushed from the data center to you with all these features. So SPICE is the open protocol. You can go to the website and take a look at it. You have drivers for Linux and for Windows, right? So it's for virtual desktop infrastructure protocol. So what's the architecture look like? So this is maybe a bit technical, but I mean, just bear with me for a while. Oops. Okay. So this is what we have, right? This is the web UI. Everything's running from here. It's from oVirt engine. They call it oVirt engine. It's based on Java. It runs on JBoss, right? I don't see why it cannot run on another Java runtime, but it's run now. It's being bundled with JBoss because JBoss is open source also. And the identity management will come. From either IPA or Active Directory. So IPA is a Active Directory for Linux world, right? If you know Active Directory, so we have something like it for Linux. We call it IPA. So you can go. It's already bundled in Fedora. It's in RHEL supported. You can go to the website free IPA. So if you love identity management, you should take a look at it. So it's a way to manage identity. Okay, which user login and everything. Or you can use AD, and the database backend is Postgres, right? On the other hand, we have a RESTful API where you can send command using RESTful directly to Ref. We have that infrastructure. We have an admin portal based on GWT, Google Web Toolkit. So that admin portal able to access using any web browser. You use Firefox, you use Windows, Internet Explorer, or you use Chrome instead of it. And now we have the CLI. I think this is not even on production for Ref yet. It's already in oVirt. You can take a look. It's based on Python, so you can use your Linux CLI Kung Fu to manage Ref. So not only to manage oVirt, sorry. Not only using GUI, you can even manage it using command line. So there's a set of commands that you can interact with Ref, with oVirt, sorry. So we have our user portal where user can log in, get their desktop, get their server, being pushed to them. So this is for the user, that is for the admin. So admin, you can install new virtual machine, you can manage policy, you can manage network. So for the user, when they log in, based on their identity from either authority or IDA, they can see which desktop is available for them. So for example,
one question, sorry. Yeah, okay, you say you can use multiple browsers to stream the desktop, right? What technology does it use to stream the desktop? Is it has an end user client, or is it on the browser like ActiveX or something?
okay, for Windows we use ActiveX. For Firefox we have a plugin. It's an XPI plugin. It's a plugin. So you have to install the Firefox plugin. Then it's gonna.
So it's not really, you don't need to install a heavy kind of client.
Just the browser plugin.
How about Chrome?
Oh, good question. I should ask you. See what.
Sorry, I'm not sure if open.
Wait, Chrome able to work on the admin portal, right? Because admin portal, we don't use any fancy technology. But to deliver the desktop, you have to use either Firefox or IE. Right? For the admin portal, it works. Chrome works, but not on the user portal. I don't know if there's already plugin for that.
I love Chrome.
Chromium, minus 200 yesterday.
Awesome.
So you have the CLI, and then on the other hand, for the host, meaning on your hypervisor, so we have oVirt to manage the host. We have VDSM for multi-node protocol, meaning how to manage multiple hypervisor node. So this is for local management. This is for multi-node environment management, right? So meaning VDSM is to manage multiple hypervisor nodes. So you have multiple servers, so you can manage that multiple server. That protocol we are using something from VDSM, but locally start, stop, virtual machine, everything comes from oVirt. So you can have local storage if you want. So you have your VM here, and you can install the agent so that you can see the IP address, what application is installed, all those information. You need to have the agent, right? So Spice comes from here. So if you're from a client, either Linux or Windows, you can use Spice and deliver your desktop to you, right? And we have shared storage. So you can use Fiber Channel, you can use iSCSI, you can use NFS, or you can use your local storage to store the virtual machine, right? So clear? Everything here?
Yep.
Clear?
Yep.
Good. Oops. Okay, so this is the engine core. You have the authentication, authorization, and audit. This is your AD, your IPA. So you have your inventory, whatever that you have in your environment. So you have host register, host monitoring. So this is, firstly, you have to register your host to use in open environment. Then you have host monitoring. What's the RAM look like? What's the CPU utilization looks like? How many RAM is already being used? And you have maintenance and host fencing. Host maintenance is where you can put your host in maintenance mode so that any VM inside there will be moved out, take out the server, and you can maybe upgrade the RAM, upgrade the CPU, repair anything on your server, or anything that you need to do for server maintenance. So we can even go into the maintenance mode. So you have host fencing, meaning they fence the host for the virtual cluster. And then network configuration, you can do VLAN tagging, you can do multiple, means you can point one network card for DMZ, another network card for local network. So all the stuff is at the local network area. You have the storage configuration and monitoring, so you can do multiple storage. And we have all the VM lifecycle, create, schedule, snapshot, meaning you can, for example, you can do a template for your virtual machine. So you install the Linux with MySQL, you make it as a template. So the moment you need another Linux with MySQL, you just right click on the template, deploy. So that template is going to be installed. You don't need to reinstall every time you need a new VM.
So right? The template is something like what format would you need?
Tell me.
You store it in a file, or you just do it inside your portal?
Okay, we do it inside the portal, okay, and then you get stored in the storage. Okay. So the moment you need it, you can deploy from that storage area. So you have load balancing, and you also have high availability. Okay, so enough of this. Everyone okay? Still okay? So we go just by some of the features that I want to highlight, right? Some of the areas that should highlight. So when you do for virtualization, sometimes people call it slowerization, because the moment you do virtualization, everything is going to be slow, right? Because there always some penalty or some what we call some performance hit on your server because it's not virtual, right? So people ask question, will KVM oVirt able to handle enterprise workloads and achieve near bare metal? So bare metal is actually if you're running it on the hardware itself without virtualization. So KVM hypervisor is based on Linux, so it's an OS. Is it really fast? People keep asking that question. So I think the slide yesterday do the justice already. So this is the one actually I deleted yesterday. There's no benchmark for Hyper-V and Zen. I don't know why, right? So we are the oVirt KVM. KVM is actually the best performing hypervisor on the 2-socket, 4-socket, and 8-socket. The only one in 8-socket environment, right? So no Hyper-V, no Zen. Maybe you should ask them. I don't know why. This one, I don't know how to show that, but this is for SAP. So they have running on this architecture, they actually have only 1% overhead, and SAP is a very, very heavy application, right? So don't ask me where I got this, but I think it's on the Red Hat reference architecture or something, right? See what? First time seeing. So KVM is fasterization, it's not slowerization. It's as fast as this, right? That one may be Zen behind that. So this is KVM.
Hey!
So what about scaling? So can we scale? So in terms of scaling, in terms of host cluster, so this is actually from REF. I think oVirt might be able to support more nowadays, but we can do up to 200 hosts per cluster. So it's very, very suitable for cloud computing environment. Whereas our friend there can only do 32. Right? What it means is that you can do failover, right? So any server down in your cluster, which machine going to be migrated to another host. So a limit for a leading proprietary hypervisor with that name over there can only do 32 hosts per cluster. But KVM oVirt able to support 200 cluster, meaning all that 200 server can fail over together, right? So if any node around that 200 fails, so it's going to move to another one. So we can support up to 200 hosts. It's very good for cloud computing. Then on the host, maximum logical CPU is 160. So maximum RAM per host is 2 terabyte. Maximum virtual CPU per host is 512. So this is actually from oVirt RAM 3.0 based on Red Hat 6.2 kernel. But the newer one I think is already 128. So we support 128 virtual CPU per VM. And this one 8 virtual CPU. If you go for another subscription, you get 32. Then per host, this is already being improved to 2 GB if I'm not mistaken. Then that is for VMware 1 TB, right? And we have memory scalability. So this is KSM yesterday. I missed this slide yesterday. So what it does is, I mean, this is not really, I have to be very unique to KVM. Other virtualization already have this. Zen already have this. The new one, Zen 4.
Zen's one is similar to ballooning.
Oh, ballooning. So still doesn't have this.
Not like this.
Right. So what KSM does is called kernel same page merging, or another one they call it kernel shared memory or something. What happens is, say for example you have a RAM, right? This is a RAM. Imagine, so your RAM maybe is 8 GB. Okay. So you have 3 virtual machines. So 3 virtual machines, for example, we give Windows 10. So Windows 2008, Windows 2008, Windows 2008, right? So this is 2 gig, 2 gig, and 2 gig. So you give each Windows 2008 2 GB of memory. So for example, you are under memory pressure. Maybe out of the 10 nodes that you have, maybe 4 already down. So you only have 6 hosts running. So the environment is under very intense memory pressure. So what happens is, when that thing happens, KSM will scan the memory in your virtual environment, and then we check if there's any footprint that is there any memory that is the same between multiple VM. So when it detects, for example, this block here is 1 gigabyte, 1 gigabyte, 1 gigabyte. So this is 2 gigabyte each virtual machine, right? So 1 gigabyte memory is the same. Is actually similar between multiple virtual machine. So they will put this similar memory block into a single physical memory block. So for example, before this you need 6 gigabyte because 2 gig is 6 gigabyte. So with 1 gigabyte is similar between multiple VM. So they mount it here, read only, and what happens is this virtual machine now requires 1 gigabyte, 1 gigabyte, 1 gigabyte, and another gigabyte come from here. So you already save 2 gigabytes. Right? You only run you need 6 gigabyte before. After KSM running, you need only 4 gigabyte. So another 2 gigabyte can be given to another virtual machine. So that's the KSM technology. Okay, so how about security? So we have SC Linux, the one that you always turn off when you install CentOS and Fedora. So this is the first thing that you turn it off. So what happened is, okay, if you turn it off before, maybe you should turn it on back. But don't ask me so much about SC Linux. Ask Siva if you want to ask anything. Alright. So for example, you have a kernel. So you have multiple this image of your VM. So on top of that, you have 3 virtual machines. So virtual machines get their image from the disk here. So what happened if one of the VM web server, VM web is being infected, right? And it's being compromised. And and then it gets a privacy escalation. So this is one hardware, 3 VM, okay? One hardware, 3 VM. So what happened is, now your machine might have a hypervisor vulnerability, so infected all the VM and the hypervisor, and might be even the disk image. Because before this, you only run one application, one OS, one server. If that server is going to be infected, it's only one server, right? But now, if that host is going to be infected, it might be 3, 4, or worse, maybe 10 VM belongs in each server. So what this SC Linux does is it protects your it protects your VM by isolating each of the VM, sometimes based on its role, based on its roles and something. So what happens is your VM web is isolated, your sales is isolated, your payroll is isolated. So during any vulnerability, it will be confined in its environment. And this SC Linux is being enforced from the kernel, so it has a very low level permission. And so anything that being enforced by kernel, application cannot, more or less cannot override, right? So it's very low level instruction. So anything happen, it's going to be confined and isolated inside the VM itself. And of course, if you don't turn it off, you can actually SC Linux your web server, your DNS, and your MySQL inside the VM itself. If you don't turn it off, right? And if you configure it properly. Okay, everything clear?
Yes.
So in terms of support, so sometimes open source has this problem where we have very nice technology, right? Very good technology, but not all the industry support whatever we do, because there might be a 800-pound gorilla proprietary technology already in the industry that needs industry support. So what is the support from the for KVMs like us? Right? So now we have this Open Virtualization Alliance, where the idea is to bring KVM to enterprise and get major support out of it. So you can see, so you can see here, most of the vendors support them: EMC, Dell, HP, even SUSE. I think there's Canonical logo somewhere, right? Maybe behind me. I didn't see it. So enterprise DB, Xenos, Cloud Sigma, all this. I mean, there are lots of support, especially if you can see the hardware vendor. We have HP, Dell, Fujitsu, IBM, Intel, AMD. Everyone is there. So the moment you buy your next hardware for virtualization and you want to run oVirt and KVM into it, so mostly it's going to be supported, right? It should be okay. You can buy them, run oVirt, it is supported, right? But not supported in terms of enterprise support or something. It can run, Right? There's already multiple companies that support KVM as a technology that when they do enablement for their product, but not in the same way support in terms of you can call them and report your problem, but it's enabled on the hardware. Alright? So this is also the most important question in run Windows. So you can run, no problem. You can run, install it as usual. There's even the driver. I don't know the exact position for Windows driver for oVirt, but for KVM itself, there's a driver for it. So you maybe can take a look. But for enterprise supported Red Hat enterprise virtualization, we have the driver, right? So it should be there in open source. So manageability, so oVirt is really cool. I don't know how to use command line. I know how to use GUI. Okay. So it's demo time. Okay. Hopefully the demo works. It's not locally. I need to connect to outside my another server. So hopefully it works. Touch wood. So maybe we can take a look at it. Right?
Everybody stop torrenting.
No, it's using this my handphone. Should be okay. All right. Okay, so to use oVirt, you have to log in. Okay, by default, you don't need to have IPA or AD. They're going to create a single user for you called admin. So from the admin, you can give him his password. So if only you want to use it on your own or in quite a small environment where you don't need multiple users, you can only use one user's password. It's already adequate, right? So this is the environment. So you can see here, this is the data center. So you can see I have, data center is essentially resources. Your local, your disk resources, your network resources, your server resources. So for example, if you see here default, the storage type is NFS. So I'm using NFS, status is up, compatibility version 3. So you can see here, this is the storage inside that NFS. And you can see what is the host. Then you can see the network, okay? And you can see the virtual cluster. So I'm using the default virtual cluster and permission one user. So what does this mean by default virtual cluster? In this virtual cluster, you can see how many hosts. So only one host, alright? So this host is actually the same host for oVirt manager, the same host for oVirt hypervisor. So I'm using one computer to get all this, right? You don't use this environment, but good enough for demo. So you have your virtual machine, your logical network. So there's only one logical network here, and permission for admin. So this is the host. So if you click the host, you can see what is the version. So the OS version is Fedora. So I'm using Fedora 16. Kernel version 3.3.1, KVM version, I'm using KVM 0.15, VDSM version 3, Spice 10.1, 0.11, then you have the iSCSI initiator name, if you use any iSCSI stuff. ActiveVM, so no VM is running. Memory page sharing, this is KSM, so because there's no VM running, so it's inactive, so it's not be running. So KSM is only will be running when in time of need. So you only run when maybe you need a memory, you are under memory pressure and stuff like that. So, but you can configure it to be more aggressive or less aggressive. Okay. So this is the large page. I think something to do with enhancing performance for your database. So how many CPU I have? I have 8 CPU. CPU name Nehalem, Intel Nehalem version. CPU type Intel Xeon. The memory is 8 gig, swap size is 10 gig, and shared memory is 0. Right? You can see. No, it's on somewhere in the server. This is not local. Yeah, I'm tunneling it. Right. So this is the storage that you have. So okay. So you can see the storage. So this is a local storage. Although it's NFS, it's local. So I'm using still local storage. This is the size of storage. This is how much is available and how much you already be utilized. Data center, VM import, and all those stuff. This is your VM. You click, for example, Titan. So you can see this is other type of operating system, and priority is medium, policy disabled, and stuff like that. Windows XP, Windows XP using Spice. You can get all the information on the network itself and everything. So all GUI, alright? Then you can have a pool. Okay, this feature is not implemented yet. So it's already in ref, but I think they are porting it to oVirt. Then this is the template. So blank template is always available, meaning you start from blank, but this is where all the template is. You can put your MySQL, Linux template, your Linux Apache MySQL template, everything is here. And this is the user, right? From this thing over here, you can see okay, this is local store, it's not running. So you can see your storage. I have 3 storage templates. I don't have any templates, and how many cluster I have. So default cluster, then how many hosts, and what's the VM running. So everything you can see from a tree structure on your left, or better still, you can search by contact. So for example, if I'm in virtual machine, so I want to look for VM with OS equals to say Windows XP. Okay. So you're going to show only Windows XP. You can save it as a bookmark. I think somewhere here got bookmark. Because the screen is being used, so there's a bookmark here. You can do bookmarking, or you can say, for example, OS equals to. So they're gonna be assist you. So you don't need to be a genius. Just put whatever you want, and it's gonna be there, right? So for example, I need what? Okay, from VM context, template, events, everything is there. They're gonna assist you during your search, and you can bookmark it. Right? So this is any alert. So you can see the alert, whatever happening inside your environment, events, all the stuff. Right? This is your bookmark. If you do any bookmarking, it's going to be here by OS or by data center or by cluster and stuff like that. And this is the tag you can even do tagging. So you can tag certain virtual machine, certain set of virtual machine under one tagging and all the stuff. So, anything? Question here? Actually, to run it is just clicking display, but something wrong that the VM couldn't run.
So how do we start the OS?
Just new server. Okay, you just choose your data center. What's the name? So, for example, FUDCON. So, description. Alright, template is blank. How many RAM you need? How many CPU cores that you need? So, for example, this one we change to 1 GB. So, we're going to change it to megabyte. Right? Then I use using Spice or using BNC, USB policy. Host, you want to run on a specific host. This is the highly available, the one that if it's down, it's going to be restarted on another host. So you must take highly available, and this is by priority, meaning, for example, in that host you have 3 VM. One VM is high, another one is medium, another one is low. So the moment that host is being down, when it wants to restart on another server or another host, it will check the priority level first. So the high priority which machine will be started first. Then the medium, then if there's any more memory, then only the low is going to be running. If not, the low priority VM will not be started if there's not enough memory. So you can put priority. Okay? So torrent server is always low, torrent server. So storage allocation, you can allocate storage. You can do your boot option. Okay, first boot, you want to use hard disk, CD-ROM, or you can do PXE boot. And this is custom properties. If you want to do some special function, for example, you want to PCI pass-through, you want to run SRI OV, all those fancy stuff that needs some customization, you put it here. Right?
So this is doing the virtual hardware, not the OS.
No,
just a hardware, just the virtual machines.
this is for the VM. Okay. The hardware is just a node you can download, install it, and we ask you a few questions. I'll show you a bit later, right? So any question here? Oh, I'm between you and lunch. We only have another 8 minutes, I think.
Kita makan dulu.
Right.
I just want to add something. One of the coolest features is the REST API. All these operations you have seen here, you can do it with scripts with the help of the API. For example, creating new virtual machines and stuff like that.
Do they actually have a bundle library for that? Like a Python library for that? A Python library to wrap?
Yeah, there is a Python API.
Okay.
Yeah.
So the gems and whatnot.
Siva, what's the link for the API?
What's the link for the API?
I mean, from here you can see the API, but what's the link?
It is, I think, just /API/VMs without web admin.
Before web admin.
No, I think that's a URL.
API and /VMs.
Slash.
Yeah. Slash.
Oh, so like slash.
VMs, sorry.
S.
Yeah.
Enter your ref your
Add internal.
Okay. The out.
Admin add internal.
Oh, admin.
The authentication is via
HTTP.
OAuth.
So this is the API.
Yeah, and then, for example, you see the actions in these links for shutdown, start, stop, suspend, export, etc. Further below, you see the disk definitions. Then further below, you see status. It's now down. You see the number of cores and a lot of other informations. And you can also create a virtual machine by just providing us informations.
You use poster, something like that in your Firefox. You use poster to post the
Okay.
post, right? Poster. So you can post, I mean, you can create your VM using just RESTful API, and the VM will be created for you. You don't need to go through the UI if you don't want to.
Okay. But there is a real library to wrap this. I mean, yeah, it's not that hard to do on the scripting language, but better not to.
In the oVirt project, there is the Python binding.
Okay.
In Rev at the moment, that is a technology preview.
Okay. So the authentication is HTTP basic out or OAuth or was it something else?
No, it's the same authentication.
So it's just a HTTP basic out.
Yeah,
Okay.
I think so, yeah.
So they follow
I'm
the
not sure if it's basic or if it's the stuff.
If it's the password is now using that form you entered, then that's basic.
yeah, this basic out.
The browser
So that and they follow the whole REST convention.
Yeah.
So opposed to
And there is actually a wrapper API, so with the oVirt SDK, you can access all these things directly to objects.
okay.
So you don't need to parse XML structures and stuff like that.
It's not hard, but better not to.
And for Ref, it's available in the ePel from Fedora.
Okay, just quickly, I think another few slides on it. So we have the installation using something BIOS Lite. So meaning you just download the CD, and then the CD you put, and then you install it, and then you change your network and everything. So you don't need to have a full-fledged Fedora to do your virtualization. You can just use the node. I mean, there's a special node just to do virtualization for oVirt. And we have reporting. So this is actually Jasper reporting. We have that in oVirt, so you can do reporting, trends, and all those stuff. I think the new one, they even have the ETL from Talan, something like that. So in oVirt. So lastly, this is reporting, and so questions. That was my presentation. Yeah.
Can we go lunch yet?
Yeah, of course you can go to lunch. So, any questions? Okay, everyone okay? Alright, so thank you for your attention, and hopefully we can do some over stuff, right?
Yes.